So, okay, so this workshop is going to cover some general topics on how to approach the assignment. I think you all have started the modules, so you have an idea of what to do. But before we begin, please make sure you have all your updates in the Autodesk desktop app. It will ensure that your web will run smoothly. Also, make sure to install the packages that I'm recommended. For this assignment, you may be only will be using Clockwork and maybe Quads and Launchbox, but for future assignments, you'll be using the rest. So please make sure to go to Dynamo and then search for a package. Also pay attention to the version, because sometimes it changes through time and nodes are depreciated. So just make sure you have all this installed. And then let's start. So as Glenn mentioned, this whole module is about design. So I would encourage you guys to look for inspiration in other architects or other structures that are already built. For my case, as a civil engineer, I don't know a lot about design. So I took inspiration from a couple of other architects. If you really want to dig into this, I would recommend looking for an architect called Santiago Calatrava. He designed the Oculus in New York. This one in the middle is also one of his projects. And then the one in the right, it's the Serpentine Pavilion in London. It was a temporary structure, but it kind of shows a lot of parametric design going on. Or if you are good at design, I would just recommend to follow your instinct and create new shapes. For this example, I chose a building that I know since I was a kid. This is an old church in a city in Colombia. It was built in the 60s, and it's a very simple structure in terms of just concrete and rebar, but it's a very thin shell. So I thought of recreating this geometry in Dynamo for this workshop. So if you look closely, this surface is kind of defined by circles. The base circle has a sine or a periodic wave around, and then the top circle is just a plain circle, and there's a curve in the middle. So the way I thought of doing that in Dynamo was by defining my three circles, and then using things that we've covered so far, such as pointed parameter, ranges of points, and sine waves. I could give some heights to the base circle, for this case, the picture in the right, to create that shape that we saw earlier. Of course, try to leave everything parametric so you can play around with the amplitude, number of waves. So I was hoping to show you guys a live demo of the Dynamo. I'll try later to see if my computer is working okay. If not, I'll share these slides and the recording with you as well. So this is how I created this wavy circle. What I did was use the point by cylindrical coordinates. So in Dynamo, you can define a point by coordinates just on the XYZ space, or you can define them by cylindrical or spherical coordinates. In this case, I thought cylindrical would be really easy because they just require a coordinate system, which is the CS input right there. The CS is set by default to the origin of the project, so you don't have to fill in anything. The angle would be a sequence of numbers from 0 to 360 degrees, but I don't want all of those angles, so I just defined 120 points. Then, using those angle or those points in between 0 and 360, I just used a sine wave, multiplied the angles by a multiplier to get 5 curves. So as you can see there, it makes the shape more interesting. And then outside of the sine function, I use just an amplifier to give it more amplitude to the wave. Um, Also, please make sure that this wave right here is kind of going underneath the floor of Dynamo. So I have to offset, and that is the slider on the lower left, height offset, which I'm later using to move everything upwards in the Z axis. So after we have this base shape, remember we had these other two circles, which we also can split by parameters. And we can create like a sequence of points that have the same number of points in the three circles. So using a NURBS by curve, we can get to these longitudinal lines, which are pretty much the base of all the geometry. Here, I'm not using anything crazy. I think you have all seen this in the previous module. It's just a point at parameter. And transposing these curves, these points, because I need I need to change the way data is coming out of curve point at parameter. So make sure to understand the list management of the geometry. Sometimes information flows in a certain way that you have to play around with the indexes or transpose lists. That is a very common operation in Dynamo. And then I also can do a surface by loft. Surface by loft is very simple. It requires cross sections, and then it lofts the surface through them. In this case, my three cross sections were just this, my three circular shapes, and that's it. Also, using the curve parameter and NURBS curve, I can create like the ribs, as Glenn called them, or the longitudinal and transverse beams as well. Now, you might encounter some issues as well, depending on your shape. These issues happen when you try to do a surface by sweep, which we'll also cover in Grasshopper later. But essentially what a sweep is doing is trying to carry a profile along a path. That's what this node is doing right here. So our path, of course, would be the NURBS curve, which are in this case the longitudinal lines. And then to make sure that we're sweeping the right profile, we have to create it at the very end of each curve and on a plane that is normal to the curve. So for example, we cannot just create a section here in the XY plane and try to sweep it along these curves because they don't match. So we have to kind of transfer the shape to the starting point of the sweep, and then Dynamo would be able to sweep it. To do that, this is a very efficient way. It just using the node curve plane at parameter would be able to define at what parameter in the curve we want a plane that is normal to that curve. So for example, I said here, to all these curves, find the 0.3 parameter. Think of it as 30% of the length of the curve. You will put a point there and you will get a plane. So this plane is going to be my base to create a rectangle that has a width of 0.5 and a length of 1 unit, because that's the unit by default. And then this node would give me a series of rectangles that will be all at the 0.3 parameter of each curve. And then I can easily sweep it. Now, sweeping is very useful, but it has some problems. Sometimes when your curve is too curvy and your profile is big, there will be self-intersects between your sweep. As you can see, well, that's pretty self-explanatory. And this is a very awkward error to find in Dynamo because it can happen very rarely, and it can happen in some curves, and in some others you will be okay. It's all depending on the size of the profile and the curves, like the curvature. A workaround that I would suggest is use the node called curve by iso curve on surface. So this node takes any surface and finds the isocurve, which is, okay, so to explain isocurve, I would go back to the primer, where it shows us how UV coordinates are mapped on a curvy or on an irregular surface. Imagine UV coordinates as being XY coordinates on a plane, on a regular plane. So our isocurve is a line across this surface that has constant U or V values. So you can get the isocurve along this curvy plane. The isocurve around the V coordinates would be this one, any of these lines. And the isocurves around the U coordinates would be this line. So by using this node of isocurve on surface, you would get smoother curves that will still represent your geometry. So take a look at this image in the right. The curves down here, they are pretty spaced out. I think those gave me no trouble. But when I tried to sweep the ones up here, the section was too big for the curvature of the path. So I changed my approach and I used isocurve on surface. That's just a suggestion in case you find problems with the sweep. And then once you figure out your longitudinal and your transverse ribs, the method I would choose is sweep by curve, as I mentioned. One thing is, don't feel forced to do the sweeps in Dynamo. You can actually get the curves. So once you have these curves, you can use adaptive components in Revit to place your geometry. The adaptive components that we've seen so far are point-based, so you would have to change a little bit your approach. For example, let me see if I can annotate here. So adaptive components by points would require, for the longitudinal beams in this case, will require a point here, a point, so our second radius circle was around here, and our third would be here. These 3 points would be just enough to create this shape in Revit, in the Revit environment. However, for the transverse curves, you would need a different approach because they are kind of, they have more points to get the shape. So what you could do is you could choose a 2-point adaptive component and kind of straighten out all of these segments, which also will help you when you get to the panelize part. Okay, so this is not very clear, but what you would have to do is to break these curves into just start and end points, and then start drawing straight lines instead of curvy ones. So there's many options really. You can try all of those. So the last part of what I wanted to show you here is for those that are taking 4 credits, something that would be useful is to find patterns in your shelter, in your structure. I would definitely explore using Lunchbox for this. It has a bunch of nodes that will help you find patterns easier than if you want to take a traditional approach. So the one I have here is pretty simple. I would encourage you to try to find a more interesting one, but if you want to go with this one, it's okay. So I start with my surface by loft. Remember, this surface was created using 3 cross sections, which were the circle up here on the top, the middle circle, and the wavy circle in the base. And then that surface, I'm going to panelize it using the Lunchbox node. So panel diamond is one of the options you have in Lunchbox. And then I'm defining 90 points both in the UNV surface. On the UNV coordinates. And then the outputs of this node are pretty much just quad panels or tri panels. I went with the quad. You can play around with them. If you don't see them, try hiding or disabling the preview of the node. So if you see, sorry, if you note here, these nodes are kind of bluish and these are gray. That's because they are turned off. So right click and then disable the preview so you can see the latest geometry. If you don't do that, all the geometry will start overlapping on top of each other and you won't be able to see it very clear. So what I'm doing here is I'm taking all my panels and I'm using a method called take every whatever item in my list. So you could use the code block or you could use the node. Just look for list dot take every nth item. And it's very simple. From all these lists, it's just taking every 3 items. I played around with this. I used 2, 4, 6. I tried even numbers, try odd numbers. You can even add an offset. That makes it very interesting. This was the one I found the simpler and the most appealing visually. So this code block is just giving me a certain array of patterns. Now here, I'm giving those patterns a bit of a thickness, so 0.5 units, so that they would look kind of like thicker here. And finally, this node that I recommend you use a lot is the color by geometry. This is tricky to find, so when you look for it in the Dynamo search bar, type display by color. That's how you find it. I don't know why it's different from the name, but type display by color. And then I'm defining my color here. So the red, green, and blue, as we all know, goes from 0 to 255. And the alpha typically goes from 0 to 1, but in Dynamo, it goes also from 0 to 255. So this is like a very general overview of what would be a 4-unit submission for the assignment. Yeah. Now, are you guys still there? Let's see who we have. Okay. Do we have questions so far? Okay, so Claire, if you're still there, I'm gonna show you the Rhino or the Grasshopper version of this assignment. So I'm just learning Rhino. I'm not an expert. I feel more comfortable with Dynamo, but yeah, you can use this one as well. Can you see my Rhino screen?
I still see the presentation mode.
Okay. Okay, what about now?
Yeah.
Awesome. So Rhino, Jameson, you just joined, but I'm going to show how to tackle the assignment from the Grasshopper perspective. You don't have to stick with Dynamo if you want to explore, and if you have a lot of time, you can learn Grasshopper. So, okay, Grasshopper. I'm going to maximize this window. And that's how you open Grasshopper. I'm going to open this one. So this is pretty much what Glenn showed in the kickoff. So I'm going to go a little bit more into details. Okay, so basics, Grasshopper works in the pretty much the same way as Dynamo. Information flows from left to right. We have nodes, we have wires. The only difference is that we don't have code blocks here. So it's a little bit more limited, or it could be better if you find that code is not your thing. And yeah, and the logic changed a little bit. The graphics are I think better, but yeah, let's just jump right in. So as always, the first steps should be defining your defining geometry. That's the most important part because that's where you're going to flex your geometry. So what I'm doing here is I have sliders that will control 3 lines. So I have 3 lines here. Okay, let me show you. Okay, how do we do this? Okay, cool. So this is my Grasshopper environment. And I have 3 lines. What happened here? Wait, for some reason, this is not right. Let me open it again. So I think I screwed up somewhere. Okay. Yeah, so I start by defining these 3 lines. So we have this one, and this one. Yeah. The parameters I'm using, it's the overall length of the curves. So that's a slider, and the spacing between one pair and the spacing between the other pair. Then, once I create my endpoint and start point, I create the lines. And the way I want to modify that geometry is by using kind of like placement points. So to do that, I used a point and curve. This is the equivalent of pointed parameter in Dynamo. So the way you find this one is you go to curve here. And I think it's somewhere in analysis. Yeah, point and curve. Or you can double click and then enter the keyword point on curve. And yeah, I don't like this method of just showing a slider and not the title, but yeah, that's how it works in Grasshopper. So here I'm just getting a point in my curve. So I'm going to turn this on. And I can move around from 0 to 1. Now, this point is my reference to move the curve around. So what I'm doing is, let me show you this. I'm moving my 2 curves from the end. I'm going to translate them on a Y component. The Y here is the green axis. So I'm going to move them outwards, and the Z component is just up. So as you can see here, this one moves them upwards, and this one to the exterior or the interior. This is my resulting point, the green one here. I'm using that point as the midpoint of a new arc. So this is how the arcs look like. And that's happening for my 3 curves, except for the middle one, because for the middle, I want to keep it aligned with the global Z vector. And then for the other end, I also wanted a little bit slanted, like towards the side, but not too much. So as I move this slider, it kind of changes the way that curve is behaving. So, questions so far? Okay. So after gathering my 3 arcs, let me hide this. So I have my 3 defining curves, correct? I'm merging them. The merge is the same as list create or list join in Dynamo. So I'm merging these curves to create a loft. And the loft, again, it just interpolates all the cross sections and it creates a smooth surface. Here, there's a couple of tricky things, and it's the loft options. So for the options, first we need to define if the surface is open or closed. So, well, it's not very clear here, but it kind of went down the surface. So make sure that you have that set to false if that's how you want your surface. But the most important is the rebuild. For some reason, if you have a rebuild that is lower than 3, it will split complex surfaces into different mini surfaces. That is really problematic when you try to panelize, because you won't have control over the number of segments you'll have. So I suggest having a rebuild value of 3 or more. Okay, then it gets more interesting. So now that we have our surface, we're going to use the grid node to split it. The grid node can be found in Launchbox under the structure menu, and it's grid structure. It's this one, yeah. So our UV parameters are defined here. For example, I have 10, I want 10 segments. Actually, these are 10 points. So I would have 9 segments, yeah. So yeah, I'm just putting those values here, and the result is it's actually 2 parts, the lines and the nodes. For this case, I'm using the lines because I want to place beams kind of the traditional way, which is just getting each line and then sweeping across that line. Now there's a tricky thing here, and Claire, if you go with this option of Grasshopper, pay attention to this, because the way Grasshopper, or the way this node gives you the lines, is a bit tricky. I'm going to use a panel which is like the equivalent of a watch node to see what's coming out of this. So as you can see, there's no structure at all in the way this node gives us the lines. It's just like a plain list of values, and we have nowhere to know which one is which. Actually, let me show you that graphically, which is easier. I'm going to use a node called list item, which will give me several items of my list. So I'll put my list here, and then in the index I want to show, I'm going to create a panel, because I want several in this index to be shown, so we can understand how this node is giving us the curves. So let's try like with the first couple of curves, the first 6 curves. When using this panel, remember, and using like multi-line data, make sure to click this option here, so it breaks each one into one integer or into one number. Okay, so we can see here we have some lines. Okay, that's in the edge, so it's not clear. Let me try something like around the 40s to see if it's in the middle. Okay, that's better. So we got 6 curves, right? And it's like 1, 2, 3, 4, 5, and 6. They are not really arranged. And there's one here. No. So the order is pretty messed up. And that's a problem. Why is that a problem? Because actually we want just all the longitudinal lines and all the transverse lines to sweep. That's what we are going after. So the way to solve that is using a deconstruct vector. So this node is just taking each line and deconstructing its direction. And then, okay, so let's see how that looks like. I'm just interested here in the x component. Why? Because I drew my shape, this is like my my curves along the x-axis. You could choose either x or y, depending on how you build your structure. And these are all the values for my x component. As you can see, there's a lot that are 0 or very close to 0. This is a very tiny number. And there's some others that are 3, 4. So after going through, like just peeking through all these values, I can see that I can filter those that are 0 or very close to 0 with a larger than. This is just a conditional. It will give me a Boolean. So I'm taking all my x, all of these values, and I'm in this node, I'm asking, are they larger than 1? If they are larger, I will have a true value. If they are not larger than 1, I will get a false. And then I have a dispatch node. So this node is super powerful and it's simple. What it's doing, it's organizing my list of lines based on a dispatch criteria, which is false or true. The A list will dispatch all the true values and the B list will dispatch all the false values. So for example, in this, according to these coordinates, line number 1 is 0, so it would be marked as false. Let me show you the panel simultaneously. So the first line is false. It should go to the list B. The second line is greater than 1, so it's true. It should go to the list A. And you see where I'm going to. All the list A are those that have x coordinate greater than 1, which means they are going in the longitudinal direction. And those that don't have an x coordinate greater than 1, it's because they're going in the transverse or the y direction. So the result of that can be seen here. Here, I have all my curves that go along the x-axis. And here, I have all the curves that go along the y-axis or the transverse direction. Now, we're not done yet. There's another step we need to follow, and it's combining those curves. So I have a join. And the reason for that is because I just have all the segments, and that will make my geometry a bit choppy. If you look, I have 109, which means 110 because we start in 0. So I have a lot of lines, which are just all these segments, and I want to join them to have an easier way of using them. Now here it gets a bit more interesting. So now we have our lines, which are like our guiding curves for the sweep. Now we need a section. Now remember, as I said in Dynamo, to sweep a section across these curves, let me turn off this loft. So to sweep my curves, I need to find the normal or the frame of each curve at the beginning, so I can sweep them across. I need to find the right orientation. So that's what's happening with these nodes up here and down here. So they're the same thing, just for longitudinal and for transverse. So the first step is to define a section. This kind of differs a little bit with Dynamo, because in Dynamo, calling geometry from Revit is a little bit more complex. Here, you can just right-click and click the set on curve. What is this? It's essentially just drawing a geometry in Rhino. So I'm going to just draw a plain section. For example, I'm going to draw a square or a rectangle. And this is a piece of geometry in Rhino. And now to bring it into Grasshopper, I just right-click, set on curve, and then I go back to Rhino and click on my section. So here, this node is defined by this polycurve or this closed loop curve. Now, To sweep it, I need two things. I need my rail, which is my longitudinal line, and I need my section, which is called profile in Dynamo. So first, well, the longitudinal curves go straight. They don't have to be processed or anything, but the section has to go through this little workflow, which is quite simple. First, I need a perpendicular frame. So the perpendicular frame would give me my normal plane to each curve, which is exactly what's happening here. You see that each one of these planes is adjusted to match the parameter 0, which is the start point of my curve. If I change this to 0.4, for example, it will move all of my wait, no, it didn't move. Let's try one. Yeah, I don't know what's happening there. Okay, just use 0 or 1, which is what I would suggest. Use the 0 parameter, which gives you the planes on each surface, sorry, on each curve. This perpendicular frame is the target to orient my cross section, which is the one I just defined here. So each one of these planes is going to be a target where I'm going to throw this section. But to throw it into those planes, I need a reference point or a source. That is the centroid of my shape. So that's why I have this node here. It takes my section and it can give me both the area, which is in this case 0.76 units, square unit, or the point, or the centroid point of the shape. So when I do that, I get all of these little squares or rectangles in the right position for Grasshopper to sweep them across this curve. There's another step you need to be careful of, and it's the list management here. If you notice, I have an arrow in these two inputs, and that's called grafting or graft. That's kind of the opposite of flatten in Dynamo. And what it's doing, it's ensuring that it's treating each rail independently from each section. Let's look at the panel to see it clear. So here I have a bunch of polylines. I have 11 polylines. And here, so those are my sections, correct? And my rail, I have 11 rails as well. So I want this node to operate between the 0 polyline curve and the 0 polyline section, and to do that for all the 11, for all the curves individually. If you don't have this graph option, the node would be give you an error. So this is the result. Now the interesting thing about using a mix between Grasshopper and Rhino geometry is that you can easily change it here, and it will update in your model. So yeah, let's try something more interesting. So you can get creative and play with these different shapes. And in this case, I have defined the section for the transverse separately, so you can choose the same, for example, or create a new one. In this case, I'm going to create the same, and let's turn this on to see how it looks like. Questions so far? Okay, and then the last well, another option you can use for Grasshopper, which is way easier, is to use Lunchbox. So let me turn off some of the geometry. So we start from our loft, and then we can play around with paneling within Lunchbox. So go to Lunchbox, panels, and there's many options you can play with, and they're very easy to use because they follow the same structure. You just give the node the surface and then the UV points, the UV parameters, and that's it. Let's start with this one. What this is doing is giving me skewed quads. So looks kind of like this, but this one just give me the panels. That's not enough. I want surfaces that represent like frames. So I use the panel frame, which is found in Lunchbox, generate panel frame. You can also play with subdivide, which would account for those that are taking 4 units. That's an interesting option there. So what this node is doing, it's just creating surfaces out of my loft. Like takes every panel, and based on a parameter of the thickness, it changes. So if I want my panels to be very thin, I would give 0.1. Sorry, the space. This is talking about the space in between, in the middle. So if I want thick panels, I would use a low value, and if I want thin panels, I would use a value that's close to 1. Now we can also use the tri panels, which might be more interesting. Yeah, or the quads, which is kind of the same as the traditional method using sweeps, but this time you have some surfaces that you can extract more info from. You can even do solar analysis with this. So yeah, that's pretty much the assignment. That's what you would need to do